This video will cover using pivot longer to reshape your data. By the end of this video, you should understand the types of reshapes you can perform with pivot longer, what questions you should ask yourself before using pivot longer, and what are some options for performing reshapes with pivot longer. The R code used in this video is available on the learning management system. It will use the data file weather_wide.rds. You should download those now if you'd like to follow along. As we've discussed in previous videos, your data might not always be in the format that you'd like to perform analysis. Different applications might mean different arrangements of data, and the data format might depend on the way it was collected. In these cases, you often need to reshape your data, and by reshaping, what we mean is both the inputs and the outputs are rectangular tables, but we're going to change the numbers of rows and columns, translating information in rows to columns and vice versa. One type of reshape that you can perform is with pivot longer. This is going to make your data narrower and longer. So I want you to think of this example here, where we're going to start with the data that's in the upper left. There are rows for two different cities, New York and Los Angeles, and there are columns for the maximum temperature in 2000, 2001, and 2002. These data don't conform to tidy data principles because we're storing the same type of information, the maximum temperature, in three different columns. What we might like to do is to convert the data to something that you see in the lower right. This conforms to tidy data principles. There is a city column, a year column, and a maximum temperature column. This is the type of reshape that you can perform with pivot longer. So how exactly does this type of reshape work? Pivot longer is going to take information from row names and put it into columns. So in this case, in the upper left-hand corner, we have three column names, max T 2000, max T 2001, and max T 2002. After we reshape the data, we'd like the year column to contain that column information, those max T names, and then the max T column to contain the values that correspond to those columns in the original tables. Pivoting your data can be tricky, so before you use pivot longer, you should ask yourself some important questions which will help you construct the pivot longer command. The first question is, which columns do I want to transform or rearrange? You should note that every observation in your original data will result in one observation for every column that you transform. So in this case, we wanted to transform three columns, all of those max T columns. That's going to result in 3 times as many observations in the output data as we had in the input data. The second question you should ask yourself is, what name do you want to give to the column in that output table that is going to hold the variable names from your input table? So we had those column names, max T 2000, 2001, and so on. We wanted to translate those into the year column in this example. Finally, you should ask yourself, what name do you want to give to the column in the output table that will hold the data from the input table? Those were the actual temperature values. We wanted to call that max T in this case. So let's get ready to reshape these data and ask ourselves these questions in detail. First, which columns do I want to transform or rearrange? You can see I would like to take the information from the max T 2000, max T 2001, and max T 2002 columns and rearrange those into 2 different columns in my output data. This means the answer to my question is max T 2000, max T 2001, and max T 2002. Similar to most expressions in the tidyverse, when you want to select many columns, you can use a tidy select expression. In this case, starts underscore with, and then using the text max T, we'll select all of the columns that we would like to reshape from our source table. The second question you should ask yourself is, what name do you want to give to the column in the output table that's going to hold the variable names from your input table? In this case, we can see in the output table, I'd like to store that information from the column names in the year column. So my answer to this question is that I'd like the information from the column names to be stored in a column named year. Finally, you should ask yourself, what name do you want to give to the column in the output table that will hold the data from the input table? These are the values in those columns from the input table. In this case, they're all stored in a column called max T. So the answer to our third question is we want the data from the reshaped columns to be stored in that variable max T. Now that we've answered those questions, we're ready to actually construct the pivot command in R. So remember that we're going to reshape data, making it narrower and longer with the pivot longer verb. It takes 3 required arguments. Each one contains the answer to one of the 3 important questions you should ask yourself before reshaping your data. First, which columns would you like to transform? Remember, we decided those were the columns that were selected by starts underscore with max t. You provide that to the cols argument. Second, the column that was going to contain the variable names, we decided would be year. You provide that as the names to argument. Then lastly, the column that will contain the data from your original table, we decided it would be named max t. You provide that to the values to argument. This code on the right represents the pivot command that we would use to reshape the data. Let's see how R is interpreting each of these arguments. The cols argument is telling R which columns you would like to rearrange. In this case, we're saying starts with max t, so it will select every column in the source table that starts with the text max t. That's the 3 columns highlighted here. Next, the names to argument tells R where to store the information from those column names. In this case, it is year. That will be a column in the resulting output table, and it will contain as text the column names from our source table. Finally, the values to argument is telling R where to place the values from our source table. Here it is max t, so each value from that source table is now contained in the max t column. Now that we've figured out how to construct a pivot longer command, let's actually do it in R. I'm going to load some of my setup data. Importantly, this includes a data file, weather_wide.rds. It's very similar to what you see in the slides, but it has more columns. Let's go ahead and load that, then take a look at the contents. You can see this is a table with 8 columns and 2 rows. There is a city variable. It contains values NY and LA. And then there are several columns of maximum temperatures from 2001 to 2006. Going back to my code, I have here the exact pivot longer command that we worked out in the slides. I'm going to take this weather.wide tibble. I'm going to pipe it to pivot longer. I'll use the tidy select starts with for the cols argument, letting R know that I would like to reshape the max t columns. I'd like those column names to be stored in a variable called year, and the corresponding values to be stored in a column called max t. I'll save that to an output tibble named weather, then we'll print it out to take a look. Looking in the output window, you can see I now have a long form tibble with 14 observations. The city column contains the abbreviation of each city. The year contains information that was previously in column names, and the max t column contains the information that was previously data. Sometimes when you reshape your data, the variable names contain more information than you actually want in your reshaped output data. The example I've given you here is a good case of that. The variable names, max t 2000, 2001, 2002, and so on, contain the year, but also additional pieces of text that max t at the start. If you're analyzing data, you just want the year information, 2001, 2002, and so on. You can remove text from variable names using the names underscore prefix option. This is going to look for patterns of text at the start of your variable names and remove it as it reshapes your data. The way this works in the case of names underscore prefix is you give it a text pattern. This pattern is a regular expression. We've mentioned regular expressions in previous videos. They're a very flexible way of matching text patterns in data. What pivot longer does is it looks for the pattern in that regular expression and removes it from each variable name before reshaping. Regular expressions can be complicated, but also very flexible. The nice thing is a regular expression matching the piece of text max t is just max t. We'll take advantage of that to remove that piece of text as we reshape our data. So what we'd really like in our output data is what you see here, where the year column only contains the year information and not extraneous text. We can achieve that with this names prefix option. Here, looking for the pattern max t. How exactly does this work? When R is reshaping the column names from the source table, it sees that the names prefix is max t. It's just going to remove that bit of text from each column name as it translates it into the year column. Looking at the R code I have here, I have the same reshape command that I had before, but I've added the names underscore prefix option, again to remove the text max t from every column name. We'll run that and print out the resulting tibble. And looking at my output, you can see now the year column contains just the year information without that extraneous text. Just to emphasize how this names prefix option works, here in a slightly modified example, instead of saying that I'd like the prefix max t removed, I just say I want the prefix max removed. In this case, when R looks at each of the column names in the source table, it's going to remove that text max. The resulting column in my output table instead of having just the year information, we'll have the letter T, the piece of text that was left over, followed by the year number. And to look at this in R, here I have that exact same code where I've modified the names prefix option, so it is just max, not max T, the full piece of text that I'd like to remove. I'll run that and print out the output. Now you can see in the output window, the year column contains the letter T followed by the year number. Only the text max was removed from the column names because that's what I specified as the names prefix argument. You may have noticed in all of the output from these examples, the year column has been stored as text. When analyzing our data, we prefer that the year column be stored as a number, not as a text value. R is always going to convert column names into text values, even if all the data are numeric. So sometimes you might like to change those text values into numbers. Remember, you can do this using the asNumeric function in a mutate statement after you perform the reshape. Likewise, your columns may contain full date information. After you reshape the data, you could also use a lubridate function as part of a mutate to convert textual dates into lubridate dates. How would this work in the example that we have here? After I perform the reshape, using the names prefix option to remove the max T piece of text from each column name, I would then pipe my resulting reshaped table to the mutate verb, and I would change the value of the year using the asNumeric function. This will take a look at the text and convert it into the corresponding numeric data type. Looking at this in R, here I have code that we've seen before, where I'm just going to reshape my data and remove that piece of text, max T, from the variable names as part of the reshape. The important thing is that I'm going to glimpse the data and take a look at the column types. Looking at my output, you can see that I get 3 columns. The year column, even though it contains numeric information, 2000, 2001, and so on, R has stored it as the character data type. The column names, when you reshape your data, will always be stored in a character data type column, even if all of the information is numeric. So what we'd like to do is take this text data and convert it into numbers. Let's go back to my code. I have here an example of how to do that. I'm going to take the data, pipe it through pivot longer with all of the same arguments that we've seen before. I'll then pipe that to the mutate verb. I will take that year variable and use the asNumeric function to transform it from text data into numeric data. I'll then save that in the weather table and we'll glimpse it to make sure that that change in data type actually happened. As you can see in the output, in this case, the year variable is now the double data type or a numeric data type. This is something you should frequently take into account when reshaping your data. Often your columns contain numeric or date information, and you may need to convert them to the correct R data type after reshaping your data.